So now that we sort of understand what values of R represent, we're now going to look at calculating R and R squared in the line of best fit. We're not going to do it by hand. We're going to use StatDisk. Okay. So let me just let you know right off the bat. First of all, when it comes to correlation, the two things we're interested in are R and R squared. And then when it comes to regression, we're interested in this, which is called Y hat. That's the line of best fit. And then we're also going to talk and if you want the equation of a straight line, what two things do you need? You need a slope and what else? And the intercept. Do y'all remember y equals mx plus b? Okay, so that's what this is. Alright. So we're also going to talk about prediction and residual. That's going to come as we work the problems. Okay. So let's all work on this example. Everybody should pull up StatDisk on their computer. Okay, so now we've got StatDisk, and what is? Oh. Okay. So what we're going to do is we're going to open this data set, but let me show you how to open it. Go to Datasets, and go to Biostat First Edition should be fine. And open up the set that's called Bears. Bears. So this is saving you the trouble of typing in 1,000 numbers. The data set's right here. Okay. Now, what we're going to do is we're going to take the data and we're going to do correlation and regression on the age versus the weight. Now, do you imagine that for bears there's a correlation between age and weight? What do you think it is?
The older you age, the more you weigh.
Right. The older you are, the more you weigh. Positive correlation. And notice the direction in which we said it. We said the older you are, the more you weigh. Generally, we would not say it the other way around. So for that reason, we're going to call age our x variable and weight the y variable. Age is the input, weight is the output. Okay. So now we're going to do all our analysis. So the way that you do this is go to Analysis and click, there it is right there, Correlation and Regression. Alright. So for our purposes, we're going to ignore the significance. Now, which is our x variable column and which is our x variable column? What was our x variable? Represented age. What column is age in? Which column of the data? It's the first column. Now, what was the y variable? It was weight. Which column is that? 9. So we have to adjust that. And now all you do is click Evaluate, and there's everything. We're going to skip that part. It's not relevant for our purposes, the significance. Okay. So what do we have? What do we have that we need? Correlation coefficient R is right there. And forget that. The next thing is, what do we have at the bottom? R squared. So it tells you that as well. Okay. Now where can we find the line of best fit? In the middle where it says regression results. Now let's figure out the way that it writes these things out. It says y, which is really y hat, equals b0 plus b1 times x. So what it's telling you is that in general it's going to be the equation of a straight line. But what are the numbers going to be? Well, it tells you the y-intercept b0 is 65.15 and then it tells you the slope, which is b1, which is going to be 2.71 if you round it. So now how can we take that and write down the equation for the line? It's going to be y hat equals what? Plug in the values. Y, or y hat, equals 65.15 plus 2.71 times x. Exactly. Sorry? X is not a value. X is our variable. What does x represent? At this point, x represents age. We're writing down a formula for the line. Okay. So far we have R was 0.74 what? 7490. And R squared was 0.5610. Okay. Next, line of best fit. Remember, we call it y hat to remind ourselves that it's an approximation. Equals 65.15 plus 2.71 times x. So just a quick note, if you actually go back to the activities and go to regression, oh, right, hold on. Okay. Something that I didn't mention before is that it actually tells you the equation of the regression line on top. So here's the regression line. So it's telling you the form of the equation. So for example, if we show the regression line, notice what it's telling you. You look at the equation, what is the y-intercept? It's 19.2. And can you see how that's the intercept for the red line? The intercept, which is where it hits the y-axis, is 19.2. Furthermore, what is the slope? Sorry? Is the slope positive or negative? Slope is negative, so it's negative 0.92. So that's the slope of this line. So again, we're not just saying, oh look, here's the line on the graph. We're saying, here's the actual formula for the line. Okay. Now, what does this formula help us do? Well, it helps us do predictions. How does it help us do predictions? Well, if we were to predict, how do we predict what a 30-month-old bear would weigh? If I'm saying the bear is 31 months old, in math, what am I telling you? I'm telling you the age, which in math is what? X. So I'm telling you what X is. And then we're going to use the formula for the straight line to predict the Y value, and the Y value represents what? Weight. So that's it. So the prediction is y hat equals 65.15 plus 2.71 times what? But what's x? Which is in this example what? 31. And if you just calculate that, you get 149.16. And remember, this is a weight, so it's pounds. Okay. So again, the idea is that if you tell me the age, I can tell you the weight, or at least a prediction for the weight. Now, is this prediction going to be exactly correct? What do you think? No. It's probably going to be close, but not exact. Alright, so let's take a look here. Okay. So first of all, the average bear weighs 207 pounds. So that's something we could calculate just by taking all the weights, adding up and dividing. But I'm going to save you the trouble of that. I'm just going to tell you the average weight is 207. I'm Jungle Jim. I'm an explorer, and I actually go into the woods and I find a 31-month-old bear. Turns out that bear weighs 143 pounds. So how good was my prediction? It was good, but was it perfect? No. So now we're going to come up with a mathematical way to say how good it was. So notice that the average bear weighs 207, and the bear that I found is 143. And that difference is negative 64. That's called the total variation. And you get it by taking the actual minus the mean. What's the actual weight? 140. 143 is the actual weight. What's the mean? 207. Okay. So next, we're going to say, well, how much I predicted the bear would weigh 149.16. So from 207 to 149.16, that works out to about negative 57.84. This is the explained variation. Now, why is this called the explained variation? Why is it explained? Explained using what? What did I explain it with? I explained it with my straight line. The straight line predicts that instead of being 207, the bear is going to be 149. So the prediction or the explanation of the line is that it's going to be, it's going to be negative 57.84, or 57 pounds less. But it turns out that it was really 143. So in other words, my prediction was off by negative 6.16, and that's called the unexplained variation. And the unexplained variation is also known as the residual. And that just comes from the actual minus the prediction. Okay. So, notice that what we're doing is we're breaking up the total variation from 207 to 143 into two parts. The first part says, oh, I predicted it would be 57 pounds smaller. But the actual bear was even 6 pounds smaller than that. So the negative 57 is the explained variation, or if you like, you can call it the predicted variation. And the negative 6 is the unexplained variation, or if you like, you could think of it as the unpredicted variation. Does that make sense? Okay. Sorry? Not really? Okay. Well, why don't I give you a chance to try to apply it to a problem and see how much you can work out. So again, for the same data set, let's compare head width and neck. Find R squared, find the line of best fit. Then, if the head width equals 8.5, predict the neck size. And then, on your list of data, find bear number 46. Find the total variation, explained variation, and the unexplained variation. Okay, so let's talk about this. How does this go? Okay, right. So you go in and you do analysis, correlation, regression, and which two columns are we doing it on? 5 and 6. And you click evaluate, and there you go. So now just pull the values that you need. So for R, you get 0.8188. And what was R squared? 0.6704. Okay. Okay, there's R and R squared. Line of best fit, what's that? You got to give it to me as an equation. Y hat equals Oh. I did it to 2 decimal places, but 4 is fine. Times x. So there's your line of best fit. Next, if the head width is 8.5, predict the next size. How do you do that? Times 8.5, exactly. And if you work that out, you get 27.57. Was it inches, I think? I think it's inches. Okay, good. Now for bare number 46, find the total variation, the explained variation, and the unexplained variation. So we got to go find bare number 46. Let's go get them. Okay. Bare number 46. So what information do we need for bare number 46? Right. Exactly. His head width is 8.5. And so the head width is 8.5. and the mech is 23. So using that, how do we get the total variation, explained variation, and unexplained variation? So let's say total variation is what? What do you do? What's the general formula to find the total variation? The actual minus the mean. What is the actual? Sorry? 23. Minus the mean. What's the mean? 20.8. Notice that that's given. Okay. So you work this out and you get 2.2. Next, the explained variation. So how do we do this? You have to subtract what minus what? The prediction minus the mean. What was the prediction? 27.57 minus the mean, which, what was the mean? 20.8. And if you work, oh, I have different numbers here. Okay. So this works out to be okay, thank you. 6.77. And then finally, the unexplained variation. And what is that? Sorry? What is what's the formula for the unexplained variation? The unexplained variation is the actual minus the prediction. What's the actual value for this bear? 23. What's the prediction? 27.57. So 23 minus 27.57, which works out to negative 4.57. Okay. Do you see the formulas? Yes, no? Okay, well you have to understand what the actual value means.
I don't know. I know 20.8 is the average.
Right.
I don't understand where you get 27.57.
Because what part of the question, oh okay, right. So this bear has a head width of 8.5. So when a bear has a head width of 8.5, What's the prediction for the neck size? We just did that in the previous part. If the head width equals 8.5, predict the neck size. So the prediction is 27.57. That's how we make a prediction. And then finally, actual. Actual just means what does the bear actually have? And what neck size does the bear actually have? No, what neck size does the bear actually have? Neck for this bear is 23. Does that make more sense?